Hello, I welcome you all to your own channel MSK Learning. Now in this video we will see the dimensional analysis. So as we already know in our physics that we have a unit and dimensions, right? So the physical quantity we classified it as a fundamental and derived, right? So there we have some units and dimension like you have a force, right? Mass, acceleration, velocity, displacement, right? And so these are having some unit as well as the dimension. So fundamental physical quantity is nothing but the mass, length, time and temperature, right? So for mass we have a dimensions is m, for length the dimension is l, for time the dimension is t, and for temperature the dimension is theta. Similarly, that unit is nothing but for the mass the unit is kilogram, the length is meter, time is second, and the theta is in Kelvin, right? So here what we will do, basically we have to do the analysis for dimensions, right? So dimension and analysis is what? Let's see that. The dimensional analysis is a method of dimensions. It is a mathematical technique used in research work for design and for conducting model test, right? So here there are the certain methods by which we can generate the relations, right, for those physical quantities. Let's say that I'll give you some example that force, mass and acceleration, how they are related to each other. Means in Newton's second law of motion we know that F is equal to mass into accelerations, right? It means that the force is depends on mass and accelerations, is it or not, right? So here the force we can say it is a dependent quantity and mass and acceleration is independent, right? So there are the to generate how this relation has generated, right? So that relation is generated by the help of the dimensional analysis, right? So there are the two methods by which you can means you can establish the relations. Like one is known as the Rayleigh methods and the second one is the Buckingham pi theorems. In detail in this video we will see about the Rayleigh methods only, right? So Rayleigh method is very fundamental and very basics, right? And it is applicable only when you have a number of variables are limited up to 3 to 4, right? So once the number of variable is more than 4, then that using the Rayleigh methods or generating the relation by with the help of the Rayleigh method is quite complex, right? So to overcome that complexity we have a second method, that is Buckingham pi theorem, that we will discuss in the subsequent classes, right? So here we are seeing the first, that is Rayleigh methods, right? So here you have some statement about the Rayleigh methods, that this method is used for determining the expression for a variable which depends upon the maximum 3 or 4 variable. Just now I told you that one relation you can take like force, that force is equal to m into a, right? So if you look at the whole variables is what, that 3, that is force F is 1, mass and accelerations, right? So for generating such relation where the number of variables are restricted up to 3 to 4, we can easily apply the Rayleigh methods, right? Now then the thing is that how to generate such relations with the help of this Rayleigh methods. We have some working rule that you have to follow, right? So here just hold on, I think it's not sure that, right? So working rule for the Rayleigh method is what, that just a moment, yes. So the working rule for the Rayleigh method is nothing but let x is a variable which depends on x1, x2 and x3, right? X1, x2 and x3 variable. Then according to Rayleigh methods, that x is a function of x1, x2 and x3, and mathematically it is written as x is equal to f of x1, x2, x3. This can also be written as x is equal to kx1 to the power a, x2 to the power b and x3 to the power of c, right? So these a, b, c are the arbitrary constant, right? Where k is a constant and a, b, c are arbitrary power, right? The values of a, b, c are obtained by comparing the power of the fundamental dimensions on both sides. Means what, that just now you have seen that I told you the example that force is equal to mass into acceleration, right? So you can write this expression that x is that is f is equal to function of mass and acceleration, and further you can write in this format that f is equal to k is a constant, m to the power a and a to the power of b. A is the acceleration, right, and a and b are the arbitrary powers, right? So now what you have to do to get the relation, you have to write down the dimensions of f, that is mlt minus 2, and the dimension of m, that is m mass, right, and the dimension of acceleration, which is lt to the power minus 2, right? And then you have to equate the power from the both side, and then you need to get the power values, that a b c, and later on you have to substitute into that equation, and then you'll get the relations, right? So these are the theoretical way. So once what we will do now, we will solve one problems, right, and then we can see that with the help of the Rayleigh methods how we can find or how can we generate the relations. So the problem on the screen, please write down. So here you have a one question I have taken. The resisting force R of a supersonic plane during a flight can be considered as dependent upon the length of the aircraft L, velocity V, air viscosity mu, air density rho, and bulk modulus of air K. Express the functional relationship between this variable and the resisting force. So if you look at this problem, that what is the problem, that you have a supersonic flight is there, right, which is supersonic means whose Mach number is greater than 1, right? So while it is traveling on the air, that resistance of air is R, and it is depends on what, that depends on the length of aircraft, velocity, at what velocity the aircraft is moving, and then air viscosity, the density of the air, and bulk modulus. So you have to express the functional relationship between these variables, means what, between R, length, velocity, viscosity, densities, and bulk modulus. So first of all you can say that there are the total 5 variables. Still we can apply the what we call that is Buckingham theorems, right? So now here we go, just pause the video and write down the questions. Then here we will start it, that solution. Okay, not this one, right? So this is what you have, a solution. Okay, so you can write that the resisting force depends upon what, that is first one, it is mentioned that length, or you can say length only, right, length L, right? Second one is the velocity of aircraft, velocity V, all right, and here only third one is the what is, that is viscosity. Okay, that viscosity, that is dynamic is given mu, and fourth one you have a density, right, density rho, right, and that is fifth one, you have a bulk modulus, right, bulk modulus. Okay, bulk modulus K. All right, so here I forgot to write that this notation, that just you can write it is 0. All right, now so what we have, or how we can write that, let's say the resistance is R, it is given in the question itself. So we can write it, that is R is equal to function of L, V, and mu, rho, and K. All right, okay, then again you can write this how, that in terms of the arbitrary power and the terms of the constant, that is R is equal to K right. Actually as K I have shown you here, you don't get confused, right? That is, this k is a constant, and in this problem that one variable is given which is bulk modulus, and it is denoted by k, right? So what I'll do, that I'll use this k, that this constant k, I'm changing anything, I'm writing this as a c, right? So this c is nothing but the k as the constant, right? Don't be confused. So c, and this is, you can write, that is L to the power of, yes, so this is L to the power of a, and this is v to the power of b, all right, and mu to the power of c, and rho to the power of d, and k to the power of e. Or else again there is a conflict with c and c. So what I'll do, that this k constant is nothing but the k prime, right? So here I'm writing that where k prime is a constant, all right. So that this k is a bulk modulus. Actually we have to shown with the k only for a constant, as per that whatever the discussion we did earlier. So but there is a conflicting with the bulk modulus and that constant, so make it, for making difference, I'll use the k prime, all right. Now that simply you have to write on the dimension from the both side. So this resistance, right, so this resistance is nothing but your force, right? So the resistance here we can write the dimensions, that is, this is m l t minus 2, all right, that is force, is equal to k prime of L dimension is what? L only, L to the power of a. V dimension is LT minus 1, that is displacement by time. So this is LT minus 1 whole power of b, right? And mu is what? That is, mu is nothing but we have a ml minus 1 t minus 1 whole power of c, all right. Then this is density, that is mass by volume, so it is nothing but the ml minus 3 whole power of d, okay. And then this is the bulk modulus, that is a stress, right? So stress dimension is what? ml minus 1 t minus 2. So here this is continuation, just we don't have a space, that's why here we are writing ml minus 1, and this is t minus 2 whole power of this is e, all right. Now the question is already done, that you have to equate the power for m, l, t, and then you'll get the arbitrary power values a, right? So first of all, what we are going to do, that see these dimension formula you have to remember, right, as you already know in your physics, right? So then we can say the next step is equating the power of mass, length, and time, right, on both sides, right? So now while we equate, then we can say for m, that is what m, okay. So means m is equal to power is 1 on the right or left hand side, so 1, check it where the m, so m power c, m power d, and m power e. So your equation is like that, c plus d plus e, all right. Now then we can go for the second, that is for length, right? For l power is what? 1 here, check it here, what is the l power? L power a, and L power b, L power minus c, L power minus 3d, L power minus e, right? So we can write this, that is a plus b minus c minus 3d and minus e, okay. Now actually it is not visible, sorry. So this is what L is equal to 1, a power 1, a plus b minus c minus 3d minus e, right? Then we go for the last, that is for t. So we don't have a space here, so I'll turn the page, just hold on. Right. So this is what, again I'll show you this for the t. So t power is minus 2 on the left hand side, t power is minus b, t power is minus c, and t power is minus 2e. So you can equate it again, that is here you can write, just a moment, that is for, we can say for t, all right. So for t it is what, that ml okay, that on the left hand side you have a minus 2 is equal to this is minus b minus b minus c, right? Yes. And minus 2e, right? Minus 2e. I'll show you, just hold on. That this is what you have a expression. So on the left hand side, minus 2, minus b, minus c, and minus 2e. Okay, now so what we need to do, that we have to simplify this equation. So we can say there are the 5 unknowns, right? But equation is only how many equation we have, that is 3, right? So this we cannot simplify. So what we will do, so you can say there are the 5 unknown, that a, b, c, d, e, and only 3 equation we have just now for m, l, and t, right? So this we cannot simplify. So what we need to do, we have to express the value of a, b, and d in terms of c and e. So here I can write that there are the 5 unknowns. So there are 5 unknowns, unknown, and 3 equations, right? So for how many unknowns we have, how many equations is required, right? So better you have a 5 unknown and 3 equations, so we cannot simplify this problem. So for what we need to do, we have to reduce it, right? So or you can express the some value into the some terms, right? So here we can write, therefore express the values of a comma b and c, a, b, and d, right, in terms of c and e, right? Okay. So now the question is arising that why we have chosen only c and e, not b and c, means why we are expressing the a, b, d in terms of the c and e, why not expressing the a, c, e in terms of b and d? Actually for that we have some rules is there for in which we have to select the variables, right? The priority we have to give. So priority for the first we have the geometric properties, then we have a fluid properties, then we have a flow properties, right? So that while we learn the Buckingham pi theorems, and then we have to write down the pi terms there we required. So at that time you will get the idea that why we have not chosen the c, why we have expressing this value in terms of c and e, not this into a, b, and all those, so and so, right? So here that if as whatever I told you, that priority we have to give for the geometric, means length, distance, and all the length and height and all those things. Then you have a velocity, that is velocity, acceleration, and all those things. Flow properties like densities, right, viscosity, and all those things. So on behalf of that if you look at this, whatever the terms, that is this L is comes under the geometric properties, V is comes under the velocities, right, and the rho is comes under the flow properties. So mu and k we are expressing alone right now. So that you will clarify while you learn the Buckingham pi theorems, right? So let's do it again. That we can say from this first equation, that which we have written for m, that is 1 is equal to here, that 1 is equal to c plus d minus d plus e. So d is equal to what we can say 1 minus c minus e. All right, so now we can say here that is from m, it's better for you, that from m, that is d is equal to 1 minus c minus e. Okay, now and again b is equal to what you can write, that b is equal to, we can write that 1 minus a, and or else, yes, b is equal to, this is the equations, right, that is minus 2 is equal to minus b minus c minus 2e, right? So b is equal to, can I write that 2 minus c minus 2e, right? So now we can write again, that is b is equal to 2 minus c minus 2e. Okay, now then we have a is equal to 1 minus from the L, right? So from this equation, don't be confused, right? That is from this L, a is equal to 1 minus b plus c, right, minus 2d, sorry, minus plus 3d plus e. So already you know the b and d value that we will substitute and get that simplification. So here we can write for L, right? That is what we say, a is equal to 1 minus b plus c plus a1 minus b plus c plus 3d, right, plus e. Am I right? Right. And yes, so now what we have to do, that we will substitute 1 minus 2, 1 minus b plus c plus 3d plus e. All right, so here again this is a is equal to 1 minus b is equal to, we can write this whole, that is 2 minus c minus 2e from these equations, right, and plus c as it is. D is equal to, I'm going to substitute this, that is plus 3 into d is equal to 1 minus c minus e. All right, and then this is plus e, right? So plus e. Okay, now so this is what you have basically, that a is equal to 1 minus 2 minus minus plus c minus minus plus 2e plus c plus 3 minus c minus e, and this is plus e. Am I right? Right. So then we can say this e and this e will get cancelled. Is it or not? Right. I'm sorry. This is what you have, a 3e. Okay, I did mistake that this e will be multiplied 3. This is correct, and this is the 3c, and this is 3e, right? So minus 3 plus e is minus 2e, and this will be get cancelled. So this will get cancelled. So we have a is equal to 1 minus 2 and plus 2c, right? 1 minus 2 c plus c, and this is minus 3c, so 1 minus c, right? Is it correct? Minus 3c and minus minus plus 2c, right? And there is a 3, right? 3 here, so this is what plus 3, right? So this a is equal to 1 minus 2 minus 1 plus, so this is 2 minus c. So we already got that a is equal to this one. Just highlight this, that a is equal to 2 minus c, b is equal to this one, right, and d is equal to this one. So we have to express the a, b, d in terms of c and e, right? So now what we will do, that substituting these values into that above equation. So substituting this value in 1, right? So 1 is what, that again I can write this, r is equal to k prime l to the power of a, right, and this is v to the power of b, mu to the power of c, rho to the power of d, and k to the power of e, right? So this is what you have, a r is equal to k prime is as it is, k prime l to the power of a means l to the power of 2 minus c, and v to the power of b means v to the power of 2 minus c minus 2e, and mu to the power of c as it is, mu to the power of c, and this is what you have, a rho to the power of d means rho to the power of d is nothing but 1 minus c minus e, right, and k to the power of e. All right, so now then you can say this is l to the power 2 by c, so we can take l2 v2 mu l2 v2 and rho, we can take it out, right? So now what is remaining, that just I'll show you again. It's a little bit of so I'll show you that this is what you have, a r is equal to k prime, right, l to the power of 2, v to the power of 2, and rho, right? So what we have here, that as I have taken 2 from this common, so it is minus c and mu c, right, and this is what rho minus c minus e, right? And then this is ke. So this we can write that c is one side and e will be another side, right? So here first I'm writing for the c, that is L to the power of minus c, and v to the power of minus c, and mu to the power of c, and rho to the power of minus c, right? Into this is what you have, a v to the power of minus 2e, just you have to break up, right? Rho to the power of minus e and k to the power of e. Simply you can say this is as you have taken 2 c is there, and mu c is as it is, and c, right? So in this you have a rho 1 minus e is as it is, right? So rho you already taken, so this is what you have, a minus e, k to the power e, and here you have a v to the power minus 2e. Okay, now then what we need to do, that you can write this as a like this, that is r is equal to k prime, which is constant, and this is L square v square into rho. Then this you can write, that is what, mu by LV rho will become in the denominator, that is rho VL whole power c, right? Similarly here you have a k, so this will come v square and rho, right? And this is power e, right? So now to terminate this arbitrary power, we can use this phi term, that is r is equal to k prime of rho L square v square of phi. This is what you have, a mu by rho VL, right, into k by rho v square. Okay, so this is your expression for the resistance force when the flight is running on a supersonic speed, and which is depends on velocity, length, the viscosity of air, and dynamic viscosity of air, density, and the bulk modulus. So this is how we will execute the problem. Thank you.